We're up to week 4's focus on more practice with linear equations. Our first question says, at the corner produce market, apples cost $1 each and oranges cost $2 each. Find the cost of, and then it gives us several combinations of apples and oranges. So what I'm going to do is set up an equation that shows the cost is equal to $1 times each apple plus $2 times each orange. I'm using B for orange because O is not a good letter. So using the equation, and we plug in the number of apples and oranges for each selection. On A, it says for 6 apples and 3 oranges. B says for 4 apples and 4 oranges. C, 5 apples and 4 oranges. And then D, 8 apples and 2 oranges. So all we have to do is calculate now. 1 times 6 is 6. 2 times 3 is 6. So 6 and 6 is $12 for A. For B, for 4 apples and 4 oranges, 1 times 4 is 4. 2 times 4 is 8. 4 and 8 is also $12. For 5 apples, that's $5. And 2 times 4 oranges is $8. So 5 and 8 is $13. And then for D, 8 apples is $8. And 2 oranges is 2 times 2, which is $4. $8 plus $4 is $12. The next question says Noah has $10 to spend at the produce market. Can he buy 7 apples and 2 oranges? If we substitute the $10 he has to spend and the 7 apples that are $1 each plus the 2 oranges that are $2 each, and we see if this is possible. Well, 1 times 7 is 7. 2 times 2 is 4. 7 and 4 is 11. $10, $11. Those are not equal. So is it possible for Noah to buy the oranges and apples? No, because he doesn't have enough money. He would need $11. Question 3 asks, what combinations of apples and oranges can Noah buy if he spends all of his $10? Well, let's start with one thing that we know. He can buy 10 apples and no oranges. And he can buy no apples. And because oranges are $2 each, he can buy 5 oranges. And that will be all of his money. Since oranges cost more, he would have to give up 2 apples for every orange that he buys. So if he buys 8 apples, he can buy 1 orange. If he gives up 2 more apples and only buys 6 apples, then he can add an orange, which would be 2 oranges. If he gives up another 2 apples and only buys 4 apples, he can buy another orange, which would be 3 oranges. And if he gives up 2 more apples and only buys 2 apples, then he can add 1 more orange and buy 4 oranges. And each one of these combinations will give him or allow him to spend all of his $10. So there are 1, 2, 3, 4, 5, 6 different combinations. Question 4 wants us to use an equation that represents the $10 combinations of apples and oranges and draw and label a set of x and y axes. I'm going to put apples on my x-axis and oranges on my y-axis. Well, if I buy 2 apples, we said that he'd have to buy 4 oranges to spend all $10. If he bought 0 apples, we said that he would have to buy 5 oranges to spend all $10. For 4 apples, he would buy 3 oranges. For 6 apples, 2 oranges. For 8 apples, 1 orange. And if he bought 10 apples, he could buy 0 oranges. And when we connect the dots, you can see we have a linear graph. Now, we wrote the equation in standard form. Can we use the graph and write it in the y-intercept form? Well, y-intercept is equal to the slope times x plus a y-intercept. Well, our y-intercept is 5. What is our slope then? It's going to be a negative number because it's decreasing, and it goes down 1 and over 2 each time. So our linear equation can be either 10 equals 1x plus 2b, or it can be y equals, that's 2y, sorry, I'm going back and forth between variables, or it can be y is equal to negative 1/2 x plus 5. On the next page, we have a question that says you have 2 numbers, x and y. If you double the first number, which I'm going to say is x, and add it to the second number, which I'm going to put as y, the sum is equal to 10. So we let x represent the first and y represent the second number, which is the way we've labeled it. We're going to write an equation showing the relationship between x, y, and 10. So it says double the first number, 2 times x, add it to the second number, and that's going to equal 10. Is this looking similar to something we've had before on the last question? Well, let's find out. Draw and label a set of x and y axes. Plot at least 5 points on the coordinate plane that make the statement and your equation true. What do you notice about the points you have plotted? If we rearrange the equation by subtracting 2x from both sides, we get y is equal to 10 minus 2x. So if x is 0, 10 minus 0 is 10. If x is 1, 10 minus 2, 2 times 1 is 2, is 8. If x is 2, that's 4, so 10 minus 4 is 6. If x is 3, that's 6, so 10 minus 6 would be 4. If x is 4, then 2 times 4 is 8. 10 minus 8 is 2. And if x is 5, 2 times 5 is 10. 10 minus 10 is 0. Now, if we plot those points on the graph, let's see what it looks like. When I plot and connect the points, I also have a negative linear equation that decreases by 2 each time. Problem 1 says for each equation, find y when x is negative 3 and find x when y equals 2. So I have rewritten my equations, plugging in the variable that it gives me to find the missing variable. If I multiply 6 times negative 3 plus 8, that's giving me a negative 18 plus 8, which means that y would be negative 10. And if we subtract 8 from both sides, which leaves me negative 6 equal to 6x, and then divide by 6 on both sides, then x will be equal to negative 1 when y is 2. And we'll do the next two. When I multiply 2/3 times negative 3 over 1, that's going to give me y equals negative 2. Boom, done. Over here, if we divide both sides by 2/3, it's the same as multiplying 2 times 2 over 1 times 3 over 2. My 2's cancel, which leaves me x equal to 3. And number 3, the opposite of negative 3 is positive 3. 3 plus 5 is 8, so y would be equal to 8 when x is negative 3. If I subtract 5 from both sides, that's negative 3 equals negative x. Well, if I divide both sides by a negative 1, that gives me x equals 3 when y is 2. On the last one, this one's a little more difficult, so I'm going to stop and do the steps, and then we'll recount them. If we change both of these to improper fractions, then we get negative 9/4 minus 10/4, which would give me y equal to negative 19/4, or negative 4 3/4. And on the last one, if I add 2.5 to both sides, 2 and 2.5 gives me 4.5 equals 3/4 x. Well, to divide by the 3/4 x, we multiply by its reciprocal. So I'm going to take this, make that 9/2 times the reciprocal, 4/3, and that will be equal to x. Well, if we cross cancel, 3 goes into 9 3 times, 2 goes into 4 2 times, so that leaves me 1's on the bottom and 3 times 2 on the top, which gives me x equals 6 when y is 2. The next question says true or false. The points 6, 13, 21, 33, 99, 137 all lie on the same line. The equation of the line is y equals 4/3 x plus 5. Explain or show your reasoning. Well, I can substitute each of these points in here. If it comes out equal, the same on both sides, then yes, the point is on that line. If they don't come out equal, then the point is not on that line. On the first point, 6, 13, if we substitute those points in there, 13 for y, 6 for x, we get 13 is equal to 13. So that point is on the line. Substituting in the next point, 21, 33, let's see what happens. When we substitute that in there, we get 33 is equal to 28 plus 5. Well, 28 plus 5 is 33, so this point is also on that line. Now let's do the last one. When we cross cancel the 33 and the 99 and the 3, we get 33 times 4, which is 132, plus 5, which is 137. So all 3 of these points lie on the same line. If we substitute the points 1, 1.5, and 12, 4 into the equation that it gives us, just like we done on the previous problem, we can find out if those are solutions to my equation. Well, I know 1.5 is 1.5. If I add 1/4 and 5/4, that is equal to 6/4. And if I change that to an improper fraction, that's 1.5. So therefore, yes, that is on that line. Let's check the other point. 4 is equal to 4. 1/4 of 12 is 3. 5/4 is 1 25/100. If I add 3 and 1, that's 4, but I have an extra 25/100. So 4 is not equal to 4 25/100. So this point is not on the line. Now it says on number 2, find the x-intercept. Well, the x-intercept is where y is equal to 0. So if I plug in 0 for y, and I leave my x for 1/4 plus the 5/4, I can subtract 5/4 from both sides. And that will give me negative 5/4 equals 1/4 x. Well, to divide by that 1/4, I need to multiply by its reciprocal. So I'm going to multiply both sides by 4/1. These will cross cancel, leaving me x. Over here, the 4's will cross cancel, leaving me negative 5. So my my x-intercept would then be -5. It would cross the x-axis at -5. On the next page, we have true or false solutions to the in the coordinate plane. It says here are some graphs representing 3 linear relationships. These relationships could also be represented with equations. It says for each statement below, decide if it's true or false and explain your reasoning. Number 1 says 4, 0 is a solution for the equation of line M. Well, here's line M. The ordered pair 4, 0 is here. It is on line M, so that is a true statement. So we'll come down here and put true. Okay. Question 2 says the coordinates of point G, which is here. This was 1. This is number 2. Make both equations for line M and line N true. Well, point G is on both lines. Therefore, it does make them true. So, or is solution to both. So it is true because it's on both lines. X equals 0, which would be anywhere on this line, is a solution for the equation line N. Well, x equals 0 is on that line. So it would be the ordered pair 0, 0 would be a solution. Now, if we're talking about the line x equals 0, which would be the vertical axis of y, then we would say no, it's not a solution. But if we're talking about the ordered pair, or just x being a 0, so not the line, but the ordered pair zero, 0 is a solution. Okay, 2, 0 makes both equations for line M and the equation for line N true. 2, 0, 2, 0 right here, which is number 4. It's not on either line. It's not on line M, and it's not on line N. Therefore, that is false. It is not a true statement because it's not on the line. 5. There is no solution for the equation for line L that has y equals 0. Y equals 0 would be any line, any point on this line. Well, there's line L. Here is a point that crosses through the y-axis. No, I'm backwards. Very good, Miss Leonie. Y equals 0 would be at the origin, and therefore this is not a solution. The line L it will eventually have a solution because eventually it will pass through where y is equal to 0. So this is not true, it's false. Just because it's below it on the graph, just don't forget the graph continues forever and ever, as do our lines. The coordinates of point H are solutions to the equation for point L. If H is on line L, which it is, then yes, those coordinates are a solution. So that is true. There are exactly two solutions of the equation for line L. Line L has infinitely many points because it's a line. Therefore, there aren't exactly two. There are infinitely many, so that is a false statement. There are infinite solutions because it takes infinite amounts of points to make a line. 8, there is a point whose coordinate makes the equations of all three lines true. Is there a point where all three lines cross at the same point? I see M and N that cross here. N and L cross here. M and L cross here. But not anywhere on this graph do all three lines cross. So that is a false statement. Question 4 says select all pairs of x and y that are solutions to the linear equation 2 times x plus 3 times y equals 6. So I substituted my x and y into the equation, each one of these into that same equation, and now I'm going to see if they come out equal. 2 times 0 is 0, 3 times 2 is 6, 6 plus 0 is 6. So yes, this one is a solution. 2 times 0 is 0, 3 times 6 is 18, 0 plus 18 is 18, so 18 is not equal to 6, so this one is not a solution. 2 times 2 is 4, and then 3 times 3 is 9, 4 plus 9 is 13, 13 is not equal to 6, therefore this is not a solution. D, 2 times 3 is 6. 3 times negative 2 is negative 6. Negative 6 and positive 6 is 0. 0 is not equal to 6. Therefore, this is not a solution to that equation. 2 times 3 is 6. 3 times 0 is 0. 6 plus 0 is 6. So this is a solution to the equation. And last but not least, 2 times 6 is 12. 3 times negative 2 is negative 6. 12 minus 6 is 6. So this is also a solution. So 3 of them are solutions, A, E, and F. 3 are not, B, C, and D. I hope you had very little difficulty with this linear equations. See ya for week 5.